load factor 0.75, correct? And if it is a hash table, yesterday we discussed, its a default initial capacity is 11, load factor is same, 0.75. Only for hash table, it is load factor, initial capacity, default initial capacity is what? 11. Load factor is what? 0.75, which means 11 into 0.75. If you get some number, let's say for example 7 or 8, after 8 pairs are added to the table, the hash table size will be the capacity of the hash table gets doubled. But in case of all the remaining map, or like hash map or linked hash map, or even now in tree map also, it is 16 into 0.75. Always the calculation will be what? In capacity into load factor. 16 into 0.75. After 12 pairs are added, then if once 12 pairs are key value pairs are inserted into the map, then automatically map size will be doubled. That is what called load factor and initial capacity. So tree map also same. What methods you found in navigable set? The same methods you can find in navigable map, like head map, tail map. Their methods are what? Head set, tail set, subset. Here what? Head map, tail map, submap. I'll show you. These are the methods you can find in navigable map. And the methods you can find in sorted map. You see, both are similar concepts. Why? If you remember one, if you know the set concept, almost you got the map concept as well. I'll show you. For example, somewhere you see sorted set. This is sorted set. Now today we are going to see sorted map. Sorted map also contains same methods. Head map. In subset what? Head map, tail map, submap. I'm going to show you. Navigable map also contains same methods. Descending map, higher, lower, pole first, pole last, remove first, remove last. These methods are common for navigable map also. Let's see the methods first, so that I can write all those methods you can able to write. So first I want to write methods of sorted set, sorted map, sorry. After that, methods of navigable map. Then I'll write tree map class. Okay, then I will show you a small example on tree map. Tree map will sort the key value pairs based on keys, either in natural sorting order or sorting order based on comparator. Based on comparator. Okay. So that's, we are going to look at about those things first. Okay, in a tree map. And once it is done, then we'll go for concurrent hash map. Let's go ahead, guys. Sorry, I want to start now. Look at this. First, I want to start. Look at this, I want to start. Java.util.what? Sorted map. Util.what? Sorted map. Let's see the sorted map. Okay. Let's see, guys, sorted map. Let's start the sorted map. Guys, you can see there is an interface called what? Sorted map. Okay, sorted map. Sorted map what? Extends map. Okay. Right. So you can see a map that further provides a total ordering on its keys. That's what I told just now. Okay. See, the map is ordered according to the natural ordering of the keys or by a comparator typically provided to the sorted map creation time. Leave over that. Okay. See, what are the methods you have? Head map. Okay. Submap, tail map. You got the same methods, no? Instead of first, what is there? First key. Okay. Instead of first, what you have? First key. Instead of last method, you have last key. That's it. The same methods you can find there also. No? These methods, you know, key set, values, entry set. These methods, you know already, right? Even they are there for hash map also. We discussed already what is key set, what is entry set, what is values method, what they return. And we discussed yesterday program also. I've copied the program into document, and I think yesterday gone through the document as well. Huh? These are the methods. Now, what is it? What are the methods now? First key, return the first lowest key in this map. That's called first key. Okay, last key. Sorted map. What sorted map will do? A map further provides a total ordering of its keys. Okay, I just want to copy this statement into our document as well by keeping heading as sorted map. Sorted map interface. Okay, sorted map interface. Simple. A map that further provides the total ordering on its keys. The map is ordered according to the natural order of keys or by comparator typically provided sorted map creation time. Am I clear with this? Am I clear with this? Next, we'll go ahead with the what methods of sorted map. Methods of sort map interface. What's the first method? First key. Okay, first key. I don't want to write, please understand, I'm not writing the description because already, first method, last method, sorted set, already in the same document, you have first sorted set methods like first, last, head set, subset, tail set. Same thing is there. That's why just only I'm writing the only the names of the methods, head map. Okay. And we have tail map and we have sub map, key set, entry set, value. These are all the methods available even for other map also, like hash map or linked hash map also. Even the same methods available for sorted map also. Okay. And if you want to, if you want to call head map method, you want to get the head portion. Head portion means top portion. Means you should specify the last value, last key up to where you want to get it. That's called head map. So let me show you. Tail map means bottom one. Head map means from beginning to the given element. So when you call the method called as head map, you have to pass two key. Up to which key returns a view of the portion of this map whose keys are strictly less than 2 key. Up to that key, not including that less than. But whereas if you take tail map from that key to end of the map, including from key, that is greater than or equal to the key. And the submap is between from key to 2 key. In this from key is included, 2 keys excluded. So head map, submap, tail map. Okay, I will write. Head map of 2 key. Next one is tail map of from key. Next one is submap of from key, comma, 2 key. Okay. 2 key is exclusive. From key is inclusive. Here also same thing. From key is inclusive. 2 key is exclusive. These are the methods. These are the methods of what sorted map. Now, from sorted map, we have something called as what navigable map. Let's open the navigable set, navigable map like that. Similar concepts. Navigable map, guys. Navigable map is an interface. Navigable map extends sorted map. You can see interface navigable map extends a sorted map. Okay, right? So here you have methods like a descending key set, descending map, first entry. Here also same head map, hierarchy, lower key, first entry, last entry. Okay, pole first entry, pole last entry. I told you already. Okay, right? So these are the method that we have here. Pole is returns and removes, right? Whereas remove will also returns and remove. Okay, right? But when you come to navigable map, you don't have any remove method. You don't have any remove first entry, remove last entry. Instead of that, we have only poll first entry and poll last entry. If the map is empty, returns null, correct? But we don't have any remove methods here. You don't find any remove methods like remove first entry or remove last entry. These are the methods now. So you have the methods like descending key set, descending map, complete map, key value pairs you will get in descending order. That's called descending map, right? First entry, similarly last entry. Okay, right? So head map, tail map, and these are common. Tarvata higher key, lower key, you'll be having some, all the methods are not required, but some methods we need to know, right? Poll first entry, poll last entry. These methods are enough. So let me write descending key set and descending map. These are the methods of navigable map. I'm talking about navigable map interface. Methods of navigable map interface. Okay, we will start with the methods. Methods of navigable map interface. What are the methods? One is descending key set. You will get a set of all the keys in descending order. Similarly, we have descending map, and we have the methods like, what is it? First key, last key in the map, first entry, last entry, right? Poll first entry, poll last entry. That's what navigation, first to last, like that, etc. Anyhow, remaining common head map, tail map, sub. These are all coming from, sorted map. No? These are the common methods actually, no deflating first key and last key, because they are coming from sorted map. Navigable map interface extends a sorted map. No? So sorted map methods are inherited to navigable map also. According to inheritance, okay, the new class will inherit the methods, properties and methods of the parent class. Okay, so that's why these methods are coming from head map, tail map, sub map, first key, last key. These are all coming from sorted map interface. Our class is what? A tree map. Tree map is a class which implements navigable map interface. Okay, right? So tree map is an implementation class now. So now we are going to discuss about a tree map class. That is our class. We can create object for tree map class. But we cannot directly create an object for navigable map or sorted map. They are interfaces. But a tree map is a class. Tree map is a class. Tree map is a class. Okay. Tree map is a class. Okay, let's write. What to write? Tree map class implements navigable map. Tree map class implements navigable map interface. What is the next hierarchy? Navigable map interface extends sorted map. Navigable map interface. Hierarchy is important. Okay, extends what? Sorted map interface. Interface is extends. Class to interface is implements keyword. Class to interface is implements keyword. Interface to interface is what? Extends keyword. I told already, suppose if you want to write extends implements both in one line, first you have to start extends, after that implements. Suppose I want to create a class, child class. It should extend a parent class and also it should implement interface. I wanted a class by extending another class and also by implementing another interface. If both you want to do at a time, extending one class and implementing an interface, then first extends keyword should come. After that, implements keyword should come. First, if you write implements keyword followed by extends keyword, it's a compile time error. Okay, always extends first, implements next. If you are writing both in one line. Okay, so navigable map interface extends sorted map interface. Okay, guys, next I'll go ahead. I'll tell you next. Sorted map interface extends map interface. This is hierarchy. Okay, right. And remaining all same. When a tree map object is created, it creates with the default initial capacity 16 and load factor 0.75. When a tree map class object is created, its default initial capacity will be 16. Only for hash table, it is 11. Default initial capacity is 16. And the load factor is 0.75. Load factor is a float value, not double float value. 0.75 F we have to write at the time of writing code. For example, if you want to specify the load factor, I told load factor, not factory. Load factor value should be in between. Load factor value should be in between 0.0 to 1.0, right? Load factor should be always in between 0.0 to 1.0. Okay. Load factor default value 0.75. It's a float value, right? Let's see. We will do one thing. We will just create one tree map object. We will just discuss about head map or tail map. First, we want to display the complete map. Then we'll discuss only head map up to the key, and then tail map up to the key. Like that, we are going to discuss. And one more thing is, if you want to use any user-defined class object as a key, if you want to store any user-defined class object as a key, I told already, then our class has to override hash code method and equals method, because bucket index is calculated based on hash code of the object, hash code of the key. Correct. See, I have a question to you. Please tell me answer for this now. My question is, actually, I want to create a map object. Let's say I want to create a hash map object. I have two classes. I have two classes. Okay, one is class A. Another one is class B. Okay. I have two classes, class A and class B. What I'm trying to say is, guys, I want to store class A objects as keys. I want to store class B objects as values. Guys, I want to store class A objects as keys. I want to store class B objects as values. Could you, in which class I have to override hash code method and equals method? I mean to say that this is my requirement. See, this is map. This is a map object. It could be hash map or linked hash map or a tree map. Don't worry. Some map object. It could be any one of the map type. It could be any type. Folks, everyone. This is map. What I want to do, guys, I want to store objects of class A into these keys. I want to store objects of class B as values. I want to store like that. For example, CA1, CB1, CA2, CB2. Like this, I want to store. CA means class A object. Okay. CB means class B object, which means I want to store what? I want to store what? Class A objects as keys. I want to store what? Class B objects as values. I want to store class A objects as keys. I want to store class B objects as values. So can you tell me how do we, in which class I should override equals method and hash code method, in class A or in class B? Okay. What is your answer? In which class I have to override hash code method and equals method, guys? In both the classes, I need to override hash code method, equals method, or in only one of the classes? And that too in which class? Okay. So always remember, whatever object that you are storing as keys, these are keys, na? Whatever objects you are storing as keys, these objects must contain hash code equals method overriding. Which means these are all objects of which class? Class A. Means in class A, I need to override what? Hash code method equals method. Hash code method and equals method. I have to override these two methods in class A, but in class B, it is not required. Optional. But in class A, it is mandatory to override hash code equals method. Then only we can able to store, retrieve, and all operations we can perform. Because we are storing class A objects as keys. If you want to store class B objects as keys, class A objects as values, then you have to override hash code equals method in class B, but not in class A. Okay, that's what you have to do. Guys, please try to understand the concept now. Okay, you have to know first of all which class, in which class I need to override hash code method, and in which class I need to override equals method, like that. Right. Normally what we are doing, integers we are storing as keys, or strings we are storing as keys. In integer class, in string class, already hash code method, equals method, they are already overridden because they are all predefined classes. So we are not bothering about it. But in case if you want to store any user defined class object as a key, and another object as value, key value pair. In the key value pair, integer is not the key. It is also another object of some class. So in such case, you have to override a hash code method and equals method into that class. Simple. The class whose objects you are storing as keys, that class must override hash code method and equals method. Remember this point. Okay, na? Cool. Let's go ahead. Let's see a tree map example. I want to create a new tree map demo. Practice all these things because collections, na, listen to these videos at least for 2 times for your revision purpose. Guys, this is tree map demo program. Okay, first let me create the package name com.ashokit.cf. Then I should go with what? Name, tree map demo program. Yeah, I'm going to start with the name. What's the name I want to use for tree map demo? The name is something like tree map test. Here, guys, I want to go ahead. Guys, everyone, here I want to go ahead. What I want to do. Okay, what I want to do. I want to create a tree map object. Then I want to show you like first key, last key, first entry, last entry. Some methods we'll practice on tree map. So first let me create tree map. So tree map of, let's say string comma key type is string. Okay, right. Try to understand a tree map of what I'm storing here. Key is a string type, and value is also a string type. That's the meaning of string comma string. Key type string, value type string. Tree map equal to new tree map. Here I'm using what key as a string object. In string class already hash code method, equals method, both are overridden. So we no need to bother because string is predefined class. But if it is not a string, your own object, suppose if you want to use your own class as a key, if you want to store the objects of your own class as keys, then you have to override hash code method, equals method in your class. Otherwise, what happens? You can store the elements. Sorry. You can store the elements, but retrieval is a problem. That's why you must override hash code method, equals method. So tree map of, let's create one tree map dot put is a method. Obviously, we can pass key comma value. Let's say, for example, I want to pass IND is a key in capital letter. India is value. I mean, country code. Country code is the key. Sorry. Yes. I want to store country code is a key. Country name is a value. Both are strings only now. IND is a key for India. Key is to map with a value. I want to map IND key to India value like that. I want to map. That's what mappings. We are defining mappings, right? Yeah. Yeah. AUS is a key. And for value, it is Australia. Okay, guys. Next, tree map dot put. Let's put some key value pairs. Okay. NZ is the key. I think I use a single quote. NZ is the key. India, New Zealand is the value. Similarly, tree map dot put. We'll add multiple pairs so that we can understand. BAN is a key. Bangladesh is a value. Tree map dot put. Let's see. RUS is the key. Russia is a value. Tree map dot put. Okay. Let's say, for example, I say SK is the key. South Korea is a value. Tree map dot put. CN is the key. chain I is the value. Okay, chain I is the value. Next, tree map dot put. Let me add something. I want to add something called JP is the key, Japan is the value, something. Something like this. Okay, some key value pairs I have included. That's enough for me. Actually, how this tree map will maintain all these elements in the ascending order of the keys, right? By default, they are going to be in ascending order of the keys, which means it is going to use comparable. Already, string is comparable. If you want to store user-defined class objects as keys, your class also must implement what? Comparable. If you're not implementing comparable, at least you need to pass to the constructor comparator object. The same concept, if you know tree set very well, tree map also same thing. Okay, there is no much difference. Okay, now first let me display all these key value pairs. How can I get all the key value pairs into a set? Entry set is a method. If you want to get just only the keys, if you want to retrieve only the keys, then keys method is there. If you want to retrieve only the values, then you have values method is there. But if you want to get all the key value pairs, then we have a method called as entry set. So we'll go ahead with the entry set method. So set of entry in the last class I told this entry is type is string. This entry has string as a key type, string as a value type. Correct? Correct. So I'll say entry is set equal to tree map dot entry set method. Correct? Entry set method, yesterday also we have discussed about it. Of course, we are getting an error. Control Shift O automatically imports will come. I told entry is a inner interface or nested interface in map, right? Is a nested interface in map, right? Good. Let's go ahead. Okay, let's go ahead, guys. Now we have something called as entry set. Next, once entry set method is called, now I want to use for each loop and I want to get one by one entry. Now this is just going to display what all the system.out.println displaying or printing all the tree map entries. Entries are nothing but key value pairs, right? All the key value pairs, all the tree map entries. Okay, just we'll use a separator. Otherwise, we'll create one variable called a string line separator equal to dot repeat of 40. Then print the line separator. Okay, now for each entry, let's say entry is for each entry colon entry set. Correct? This is the way how we can write entry for each entry. System.out.println. First, I want to print entry.get key. If you want to get exactly the same type like string, then we can write entry of string comma string. Key type is string, value type is string. Na? Now entry dot get key. Then I want to write some separator like a dash. Then entry dot get value. Same, sorry. Entry object has get key method, get value method, right? Entry is a combination of key and value. I told in the last class. Yesterday we got to know about this, right? Yesterday we got to know about this. So what I'm going to do is, I will start working with sorry, I'm starting, I will run this program first. Next, we'll talk about head map, tail map, first entry, last entry, those things. Now, all the entries you got here, but they are not in the same order like how we inserted. Linked hash map will maintain insertion order. Hash map does not maintain insertion order. Linked hash map will maintain insertion order. Tree map maintains in the ascending order of the keys, natural sorting order of the keys. That's why we are getting AUS first, A first, B next, C next, I, J, N, R, K, S something. That's a difference, okay? It's easy now. Hash map doesn't maintain any order. No insertion order, no sorting order. Linked hash map maintains insertion order. Tree map maintains sorting order. On what sorting? Keys. Which sorting? Natural sorting. If you pass comparator, based on comparator sorting, like that. The same thing applicable for set also. If you know the set, you know the map. If you know the map, you know the set. That's it. Because set internal uses map. Set internal uses map only, no? Yes. So you got to know. Now we will start working with other methods too. Who are the other methods? So let's say, for example, we want to discuss about a method called as first entry. Then discuss a method called as last entry. First entry, last entry. First entry is Australia, last entry South Korea. Let's see first entry, last entry methods. So now I want to give one line separator first. Line separator. Okay. Now line separator is over. Now I want to start with what? First entry. System.out.println. First entry in tree map. In tree map object or tree map, whatever. First entry in tree map object. So who is the first entry? How can I get the first entry? First of all, tree map dot. First entry is a method. But first entry method returns entry object. It contains get key and get value. Key value pairs are there. Okay. For example, if I write first entry dot get key. First entry returns entry object. On that entry object, we are calling get key method. This is called method on method, method chaining. First, we are calling first entry method. What first entry method returns? Entry object. On that entry object, what method we are calling? Get key. So we are calling the second method on the return value of first method. This concept name is called method chaining. Chaining means what? Call the method on method. I'm calling the second method on first method, right? This is called method chaining. Second method is called on return value of first method. What's the return value of first method? Entry. On that entry, what I'm calling? Get key. Similarly, I want to print value also. Plus dash. Tell me how to. Tree map dot first entry dot get value. This is also called method chaining. Hope you guys understood this line. It's a big statement. This is called method on method. This is called method chain. Chaining methods. Nothing but you're calling method on method. This concept name is called method chaining, right? How does method chaining work? The second method is called on the return value of first method. The second method is called on the return value of first method. The second method is called on the return value of what? First method. This concept name is called what? Method chaining. This concept name is called what? Method chaining. Method chaining. Okay. What is method chaining? Calling second method on first method return value. Calling third method on second method return value. Calling fourth method on third method return value. This is called method chaining. This is called method chaining. Am I clear with you? Okay, good. This is first entry. How does the last entry? How does the last entry? I will do. Same, I just copied the same line. But in place of first entry, what should I call? Last entry. I want to display what? Last entry. Last entry. This also what? What's the method name? Last entry. First entry, last entry. Okay. Now I want to write one other SOP statement best. Now I wanted one more SOP statement. Not SOP. Now I want to use again line separator. Remaining head map, tail map, you just do. I will do sub map. Again line separator. Now after line separator, what I want to do is, I want to say sub map. Sub map means it is asking from key. So I will write look at this. It returns a map again. See what I'm writing is map of string comma string. Map is equal to, I can store in navigable map, otherwise I can store in sorted map, or I can store in map, because navigable map extends to sorted map extends map. I can store in any of the object types, because if you call the submap method, you can see submap method here only, it's there. No? You can get the submap method. What's the submap method actually returns? Submap method returns sorted map object. Okay, sorted map. Sorted map extends map. That's why I can store either in sorted map or I can store in map, whatever I can use. I can use here either map or sorted map, anyone. Okay. I can use map or I can use sorted map, whatever I want, I can use. Next. For example, I can write sorted map. I can use sorted map also. Or I can use just map also, because sorted map extends map, no? So sorted map base class is map. I mean, base interface is map, no? I can use map also, whatever. Let's say sorted map is equal to C tree map dot submap of, I have to pass from key comma to key. No? For example, I'm writing from key is IND, from key inclusive, comma to key is exclusive. For example, I'm writing SK. SK is South Korea, right? South Korea not inclusive, exclusive. Last entry is a South Korea. I want to return a sub map, like a part of the map from IND key up to SK key, but excluding SK. Okay, means up to I will get Russia or US Russia, not SK South Korea. Let's print them. Again, it is a map now. Directly we cannot print. What to do? If you want to get key value pairs, one by one entry we need to get now. Again, which method I have to call? Entry set method on sorted map. So what should I do? First write system.out.println. What's the statement I'll write? I'll write the statement like printing the submap entries. Okay. Now again, I need set of entry of key is a string type, comma value is a string type. Because when you are creating map objects, you should pass two type parameters. First one is representing key type and second one is representing what? Value type. One is key type and second one is what? Value type. Okay, I guess. Okay, let's go ahead. Let's go ahead, guys. What will we do? Set of entry of string comma string. I can write something called what I can call entries set 2, because I already have used entries set object. That's why I'm taking entries set 2 equal to sorted map dot entry set. Because already entry set I have used, that's why I'm taking 2 entry set 2. Again, the same for loop. Same for loop I need. Right? Just I want to but in place of entry set, it is entry set to TWO. And suppose I want line separator after printing this SOP, then I can add system.out.println line separator. Okay, guys. I am only just now creating an example with submap method. Later, you practice with the same example on tail map and head map and other methods, descending map. I told you, descending map is there, descending key set. You have to try the methods, don't execute same example. Further, you also enhance this code and practice it, okay? Enhance this code and practice it. That's what I'm trying to, explain you. Am I clear? Let's start. We'll execute this program now. Now you can see. Of course, this is all tree map entries. Who is the first entry? AUS. It is not insertion order. Actually, AUS I inserted as a second entry or third entry. It's not insertion order, sorted order. Okay, first entry, Australia. Last entry, South Korea. Guys, can you able to see my screen?
Yes, sir.
Okay. Okay, please. First entry, Australia. Last entry, South Korea. Now, how to print the submap entries now? From where to where I told IND to SK. IND inclusive. SK exclusive. So what are the remaining now? I got a submap from IND to RUS for Russia. This output, IND to RUS, Russia. Okay, guys, am I clear with this? This is called what? Tree map. Now, we have one more thing called concurrent hash map. Now that class also you should know. After that, we have to discuss about something called as what is fail fast iterator, what is fail safe iterator. First, we'll discuss about what concurrent hash map. First, we'll discuss about concurrent hash map. Then we'll discuss about what is fail fast iterator, fail safe iterator. But first, we'll discuss about concurrent hash map. Today, I want to talk about concurrent hash map. Some idea about concurrent hash map. Okay, right. Today, our session is a bit short. approximately another 5 minutes or so I'll explain, and remaining I'll cover on tomorrow. First, this program I want to copy for you. Once concurrent hash map, and if you know them, then tomorrow we'll also start with what are the new features including Java 8. Java 8 features we are going to discuss. Once Java 8 features are completed, then we will see about multi-threading. In multi-threading, we'll apply Java 8 features also. You will learn multi-threading in that way. Okay. So this is the example on tree map. But what I'm trying to say, you guys please go ahead and just a minute. Okay, basically this is a code, right? Okay, this is a code. So please go through this code. Please go through this code and add other methods too and practice the program. Now today, we will also understand about what is concurrent hash map. First, I want to put the heading. There is a class called concurrent hash map. I'll tell the hierarchy of concurrent hash map class. Okay, there is a class called concurrent hash map. I will show you the hierarchy of concurrent hash map for today. Then I'll talk about how concurrent hash map works tomorrow. See, I'll start with. Look at this case. Actually, we have an interface called map, as we know. Map is an interface, as we know. It's an interface. Correct. Map is an interface. Guys, what I'm trying to say, map has a child interface called concurrent map also. Of course, you know, hash map, hash table, they are classes, and the sorted map is an interface. Similarly, actually in the diagram, I forgot, I told at that time, but now I'm giving separate diagram. Separate diagram. Take hash map. Sorry, take map. Map interface has a child interface, one more child interface called concurrent map. Remember, this is also another interface. Now, concurrent map has an implementation class called concurrent hash map. Now, what is concurrent hash map? Concurrent hash map is not an interface, it is a class. So hope you guys understood this. Concurrent hash map is a class which implements concurrent map interface. Okay, guys. This is a hierarchy. Actually, this hierarchy I have to include in the map diagram so that all at one place, but I forgot at that time. That's why I'm giving separate diagram for you. Okay?
Okay,
Cool.
sir.
Now, let me keep this image.
concurrent hash table is also there, no?
Concurrent hash map.
Hash table.
Concurrent hash map uses concurrent hash table. Okay. Internal data structure is hash table for any map. Let me show you first. First, I'll add this image. Now, this is our diagram. There is something called as concurrent hash map. There is a class called concurrent hash map. Let me show you first concurrent map. Okay, right? There is concurrent hash map is a class. Class is concurrent hash map. Okay, right? It implements concurrent map. Concurrent map is an interface which extends map. What's the hierarchy? Map is on top. Map has a sub-interface called concurrent map. Because concurrent map extends map means what? Concurrent map is child, map is parent. Then we have a class, we have something called as concurrent hash map. Right? Concurrent hash map is implementing concurrent map, nothing but concurrent hash map is a class which implements concurrent map. It is a implementation class. Okay. Very good. A hash table supporting full concurrency of retrieval and high expected concurrency for updates. I'll tell you what does it mean. With this, the definition, you can't understand what is mean. This class obeys the same functional specification as hash table and includes versions of methods corresponding to each method of hash table. Okay, right? And here we also need to understand about what is concurrent modification exception that we'll discuss as fail fast and fail safe iterator concept. But currently we want to understand about what is happening in concurrent hash map. Okay. Basic thing is there is a difference between hash map and concurrent hash map. But to explain concurrent hash map, I think it is not the good time because I would like to stop here. It's better we freshly start tomorrow because we will discuss about concurrent hash map. Don't worry. Then we'll discuss about fail fast and fail safe iterators. What is concurrent modification exception? These kind of things I'll explain tomorrow.
Okay,
I'll continue further. That's better. Tomorrow I'll talk on concurrent hash map and all. Tomorrow we'll complete this first. And once it is done, tomorrow I'll just give you introduction to the new features including Java 8 after this collections topic.
Okay, sir.
I'll share the notes and please go ahead with the example and all. Okay. That's it for today, guys. We'll continue on tomorrow. Thank you.
Thank you, sir.